Hello, this is Mrs. Schroeder. Welcome back to chemistry. We're going to talk about nuclear chemistry, and specifically today we're going to talk about half-lives and how a half-life can be used to determine an object's age. So the half-life is defined as the time required for half of a sample of a radioactive substance to disintegrate by radioactive decay or natural processes. It is a constant value. It will always take this certain amount of time for half of it to decay, and we're talking about half of the half. It doesn't matter what the conditions are, the temperature, pressure, does not matter. It's always a constant. Example, radioactive isotope of iodine, iodine-131, has a half-life of 8.02 days, which means that every 8.02 days I'm going to lose half of what I started with. Now when it decays with beta decay to form xenon. If I look at the initial amount, let's say I started out at 0 days with 1 milligram of iodine. After 8.02 days, this is one half-life has passed. I have 0.5 milligrams of xenon and 0.5 milligrams of iodine, so it's cut in half. 16 days, this is 2 half-lives. I'm down to half of this. Half of 0.5 goes down to 0.25 milligrams of iodine. And then after another half-life has passed, the 0.25 is divided by 2 is 0.125. This is 24. This is 3 half-lives have passed. In 24 days, I go from 1 milligram to 0.125 milligrams after 3 half-lives. Some common radioactive half-lives, some might have things in the order of days. Some have Y is years. So it does depend on what the material is, on how fast it may or may not decay. So I want to start out with a given amount. Let's say I have this amount of a substance. We want to be able to be converting half-lives as fractions. 1 half-life is a half, is also fraction is 0.5. Okay, so after 1 half-life has passed, I have half of that remaining. Okay, this is how much remains, this orange part. 2 half-lives is 1 half times 1 half, which equals 1/4. 1/4, the fraction is 0.25, the number. That would be the red amount. So when I have a quarter left, a quarter of the square is the red part, 0.25. 3 half-lives is 1 half times 1 half times 1 half. 3 half-lives have passed, which is equal to 1/8 as a fraction. And 1/8 is 0.125 is the fraction. Again, 4 half-lives is the same, 1 half times 1 half times 1 half. And when I do that, you can see the green square. That's how much is left. I'm down to 0.0625 remaining. 5 half-lives is 1/32, and that's 0.03125. So I need to be able to be thinking about fractions or decimals, fractions or decimals for all of these when I'm thinking about amount remaining. Now, calculations involving half-lives are often solved intuitively using fractions, thinking about how much remains. And most of the ones in this book are simple enough you can solve them just by thinking about fractions. Now, there is a calculation available. The fraction remaining equals 1 half to the t over a capital T, to the time that's passed over the half-life of the substance. We're not going to use this as much. Most what we're going to do is going to just be the intuitive. I'm going to look at the fractions and figure out how much remains. If I know the half-life of something, I can calculate the amount of time remaining. I can calculate the amount of time until a certain amount remains. If I know how much I have, I can calculate the age of a sample, or the half-life of an isotope. So I can start doing some of these calculations based on knowing this half-life or knowing this amount when I have a radioactive substance. It can be very useful. We'll talk about that next time. What we want to talk about now is how do I actually do this? How do I use a fraction and figure out how much will remain? So the first thing is when I'm given a fraction or an amount, the first thing I have to do is figure out what that fraction is. What's that amount remaining? So take whatever is remaining divided by the initial amount to get my fraction remaining. Next, I'm going to relate that fraction to the number of half-lives required to reach that fraction. And this goes back to if it's 1/4, as in the example, 1/4 is 0.25 is 2 half-lives. So 2 half-lives have passed if I have 1/4 remaining. So 2 half-lives. I'm going to read it as HL for 1/4. Next, I'm going to multiply the half-life given, which you'd be given in the problem, by the number of half-lives, the 2 or the 3 or the 4, whatever that number of half-lives is, in order to determine how long it took to decay. Quick example, if I have 3 grams of a 24-gram sample, so 3 grams remains, I started with 24 grams, and I want to know what, how long did it take for this amount to decay? How old is this sample, essentially? So first thing I want to do is figure out the fraction, the 3.0 grams, divided by the initial amount, which was 24 grams. And that, when I simplify it, is 1/8. 1/8, again, go back to our chart. 1/8 right here means I have 3 half-lives. So if I have 3 half-lives, it's equivalent to 3 half-lives have passed. So how long did it take? I'm going to take my 3 half-lives times the half-life of radon is 3.82 days. And when I multiply that, I have 11.46 days. That's how long it took for the sample to decay. We'll do some more practice problems in class. I do want you to write this down. Again, we can go the other direction. I'm given the time. Given 3 half-lives have passed, or 24 days have passed. And I want to figure out now how much remains. So it's essentially backwards. First, you figure out how many half-lives have passed. Okay, based on the time that's passed. Then I'm going to relate the half-life to the fraction. Okay, so I'm going to try to find the fraction out. And then I'm going to use those fractions to figure out how much will remain. And I can do this by doing cross multiplication, setting up a proportion, or just taking a fraction, half of the initial amount or 1/4 of the initial amount to set that up. Again, there is an equation. Okay, this is the equation you could use. Fraction remaining is 1/2 to the t over t power. Small t is time, large T is half-life. But again, most of the problems in our book are set up easily enough that you can use these steps to do it. You won't need to use this equation. Okay? Again, we'll do some more practice problems in class and cover the rest of the section of why we want to use these in class. So, again, make sure you have both of these directions written down, finding time and finding fractions, or given fractions. So have both of those written down, and we'll discuss and do some more practice problems in class.